So we are now ready to determine the internal rate of returns for both the LPs, GPs, and the project. So we're gonna go, we know that we have our inbuilt XIR formula. So we take that percentage of, we take whatever cash flows that was distributed to the LPs, including their initial investment capital. We take all of those amounts, we go all the way, and then we reference the date which we need. Here is, we have to begin from the transaction date. So we reference all of that date with F4, and then we hit enter. And we can now copy this formula for the LPs, go down, Alt ESF for formulas, is special. And as you can see, the GPs hit a rate of return more than the entire project, 49.2, approximately 50%. And for the LPs, they hit a rate of return of 31%, and for the entire project is 33%. As you can see, we've kind of modeled it in such a way that after these distributions, the rate of return is equal to that which we determine for the levered internal rate of returns over a year. So this tells us how these partners, the general partners, will undertake this real estate development project for incentive reasons because of the structure that is accounted onto them for disproportional returns. So you see the hidden rate of returns after every hurdle rate is reached. So you see almost approximately 50% or half of everything in this project. So this gives you a better understanding of how real estate joint venture form partnerships. The next thing we want to do here is to calculate the net present value of the limited partners, general partners, and the project entirely. So what is the net present value? We know the net present value is just the time value of money. So we are saying that if these investors were to hold this project for the next 3 years before they have been paid these returns, what is the value of holding this investment for that period of time today? So we are accounting for the time value of money. So we go here, it's gonna be XNPV, and we have the cash flows. First of all, we have to reference the discount rate for each project, for each partner, and for the entire project. In this case, we said it's 15%. So the discount rate is the weighted average cost of capital. So this is the risk that is involved in investing in this project. So we reference that there. And then we reference all of the cash flows, beginning with the LPs. And then we have to discount these cash flows heavily back to this transaction closing date. So we are discounting these cash flows from the future into this present date to tell you exactly how much they should expect in returns in dollar value. So we reference all of those dates with F4, close it, and then we press enter. So we can now take this, we copy it, Alt ESF, we paste as formulas, and as you can see, the net present value for the GPs, we can see the net present value for the project entirely, and we can see the net present value for the LPs. So at the same time, we can also determine the cash and cash returns on this project, say that how much capital did they contribute and how much will they pay in return. So what is the number of times this initial capital investment to the total returns that they got as a result of the initial investment. So we have it set up here. The cash on cash returns. So we're gonna go by saying that we're gonna sum whatever positive cash flows. So we know that from here we should expect any number greater than 0 should be a positive cash flow. So we sum whatever positive cash flow, we sum all of those, and then we divide it by the negative sum of whatever investment amount they invested in this project. So we divide it by the sum of all of this amount here. We close the bracket, we press enter. So we can copy this, or ESF, for the rest of the project. As you can see, the GPs, they get approximately 2.5 times the invested capital, and for the LPs, they get approximately 2 times or 1.8 times their investment capital. For the entire project, it's approximately 1.9 times. So the only limitation about the cash and cash returns is that it doesn't take into account the time value of money, and as a result, we are not certain about these cash returns. But in this case, we can just say that this is what we will expect: 2.5 times, 2.5 times the initial investment for the GPs. So thank you very much. This is probably we have modeled this schedule, we have modeled everything clean and very nice. The only thing we'll have to do next is to show some sensitivity analysis, and then we will run up with this entire project to show you the rate of returns at certain changes in the sales assumptions and also development cost. So we'll be doing that in the next video.